In this second class of Chapter 5 of the course of Basic Geometry, the following topics are presented: relative positions of circumferences, positions of straight lines, tangents and secants, tangent segments, chords, equidistant. In this first slide of this second class of Chapter 5 of this course of Basic Geometry, it shows in figure 5.13 two secant circle or circumferences. We affirm that two circumferences or circle are secants when they have 2 points in common. In the case of figure 5.13, you have 2 points in common, A and B. In the second part of this slide, I present two circumferences, tangents internal and external, one to each other. In the figure 5.14, two external tangent circumferences having a common point T are presented. In figure 5.15, two internal tangent circumferences with a common point T are presented. Two tangent circumferences have in common a single point of tangents. In this second slide of this second class, two non-tangent and two non-secant circumferences and circle are presented in figure 5.16. Figure 5.16 shows two external circumferences. These two external circumferences have no points in common. In the second part of figure 5.16 shows two internal circumferences. Again, these two circumferences have no common points. Both cases have a non-secant and non-tangent circumferences. This slide shows the position of the lines with respect to a circumference. Figure 5.17 shows three types of lines: secant, tangent, and external. Therefore, the external line type has no common point with circumference in the scaled straight line E. The second line cuts the circumference or circle at 2 points, A and B, that is the straight line S in figure 5.17. The tangent line has only 1 point in common with the circumference or circle. The straight line T only touches the circumference at the point T. This slide shows the possible positions of tangent lines with respect to two non-tangent and two non-secant circumferences. Figure 5.18 shows two non-secant and non-tangent circumferences, which have two outer tangent lines common to the two circumferences. That is, the two tangent straight lines are tangent on the same side of the two circumferences. These tangents are called external common tangents. In the second half of the slide, I present in figure 5.19 two non-tangent and non-secant circumferences with two cross the tangent lines. That is, the points of tangency of each of the tangent lines are on opposite sides of the two circumferences. These tangent lines are called internal common tangent lines. This slide shows the properties of secant lines on a circumference. Figure 5.20 shows a circumference with center C and radius R, with a secant line that generates 2 points, A and B, on the curve. And these points are joined by the straight line AB. At the point of the straight line segment AB, called the point M, is drawn a straight line perpendicular to the segment AB. This line segment will pass through the center C of the circumference. In the second half of this slide, two lines are shown tangent to a circle. The two lines originate at the external point P common to both lines. In this way, 2 points of tangents N and B are determined. The segment of tangent lines PA and PB have the same dimension, that is, they are congruent. In this last slide of this second class of chapter 5 of the course of basic geometry, two equidistant chords are present. Figure 5.22 shows a circumference with the center point C and radius R. In this circumference are marked 4 points in the curve A, B, D, and E. Two line segments AB and DE are drawn. Mark the midpoints of these two line segments, points M1 and M2, which has a distance d1 from the secant line AB to the center C, and has a distance d2 of the secant line DE to the center C. If the two segments of secant lines AB and DE are equidistant, then the dimension of the two line segments D1 and D2 are equal. The line D1 is perpendicular to the secant line AB, and the line D2 is perpendicular to the secant line DE.